Welcome to the deep dive. Today we're jumping into something, well, pretty fundamental if you use a vertical antenna in ham radio, the ground plane.
Right. And for years, that's usually meant, laying out a bunch of wire radials.
Exactly. But what if you're operating portable? Those wires can become, frankly, a bit of a nightmare to untangle and deploy.
And that's where this idea of the magic carpet comes in, or Faraday cloth, some call it.
Describe that for us. It's basically a fabric, but woven with conductive metals. Copper, silver, nickel, that sort of thing.
Precisely. It's designed actually to block electromagnetic fields, like for EMS shielding. But the question ham operators started asking is, hey, could this work as a portable ground plane?
And that's our mission for this deep dive, right? To see how this Faraday cloth actually performs out in the real world as a ground plane, especially for portable use.
Yeah, we'll look at a few different experiments, but we're definitely going to focus quite a bit on the work done by Denny, K5DCC. His tests are pretty interesting.
Okay. And for you listening, we know you want the insights without getting totally bogged down in technical jargon, so we'll cut through the noise and give you the practical takeaways.
Let's do it. Starting with Denny, K5DCC. His experiment is documented in portable vertical antenna testing.
And he was using, what, an adjustable 6 to 80 meter vertical whip with a Yaesu FT891?
That's the setup. Now, just real quick for anyone maybe newer to that ground plane, it's like the missing half of your vertical antenna. It gives the signal a return path.
So it can radiate properly? Usually, yeah, that's the job of those wire radials. So how did Denny actually test the Faraday cloth against that?
Well, this is what makes his test quite neat. He did a direct comparison. He put his antenna's magnetic mount right on the ground first.
Okay.
Then he took the same setup, but put the mag mount on a piece of Faraday cloth that was laid out on the ground.
Ah, so a real A/B test. That's useful.
Exactly. It lets you see the difference the cloth itself makes.
And his conclusion, you mentioned it aligns with some other sources we've seen.
He was pretty positive. He basically said the Faraday cloth seemed like a perfect solution for an effective ground plane when you're operating portable.
Wow. Perfect solution. That's strong praise. Definitely sounds like a win for making portable ops easier.
It really does. And, thinking about why, that large conductive surface area of the cloth probably gives you good capacitive coupling to the earth underneath.
Like two big metal plates close together. That makes sense. The RF sees a path.
Right. But it's important, like always, to look at other tests, too. Some paint a slightly more, let's say, nuanced picture.
Absolutely. Which brings us to W2U's YouTube test. He compared ground radials to the magic carpet with an MP1 vertical.
And he was up front, called it an unscientific test, but still, the SWR results he got are interesting.
Okay, let's break those down. Remind us, SWR's standing wave ratio lower is generally better, means a good match between your radio and antenna.
Correct. You want as much power going out as possible. So what W2U found was, well, it depended on the band. On 17 meters, surprisingly, the magic carpet actually gave him a better SWR than the radials. It drops from around 1.3 something down to like 1.1 or just under. Very good.
Huh. That is interesting. I wouldn't necessarily expect that, but it wasn't like that across the board.
No, not at all. On 20 meters, the magic carpet was a little bit worse SWR-wise. Still usable, mostly under 1.65 or so.
Okay, acceptable.
But then on 30 meters, the SWR with the cloth jumped up noticeably around 1.8. The radials were much better. They're like 1.2, 1.3.
Right, and 40 meters.
That was the big difference. On 40, the magic carpet was significantly worse, especially up to the phone part of the band. The SWR shot over 3.1. The radial stayed below 1.65.
Yikes. So, yeah, definitely a mixed bag, as you said. His takeaway was that for some bands, maybe the lower ones especially, the radials just worked better in his test.
It really highlights that, doesn't it? One size doesn't fit all. Maybe the clock's characteristics just resonate or couple better at certain frequencies.
Yeah, unlike tuned radials, which are cut for specific bands, the cloth is just a sheet of conductive stuff.
Exactly. It's interacting with the radio waves differently.
Okay, let's talk about another test. Brett from Survival Comms on YouTube. He also compared the magic carpet to a radial kit, this time specifically on 20 meters with an MP1 super antenna.
And one thing Brett really emphasized was the setup time. He said he could get the magic carpet down and ready in under 2 minutes.
That's a huge selling point if you've ever wrestled with a bunch of radial wires in the field.
Absolutely. But his SWR results showed a pretty stark difference on 20 meters.
Oh, what did he find?
With the Faraday cloth, the lowest SWR he could get was just under 4.1, which is, well, pretty high.
Oof. Yeah. Most tuners might handle it, but it's not ideal. And the radial array?
Much, much better. He got 1.18.1 with the radials. So just looking at SWR on 20 meters in his test, the radials were the clear winner for matching.
But he didn't stop there, did he? He did some field strength tests, too, using Whisper.
He did. Whisper testing basically sees how far and how well your weak signal gets out and is received by other stations.
And what did that show? Because sometimes a perfect SWR isn't the whole story for signal propagation.
Right. And what he found over 4 days of testing was that the antenna with the radials consistently put out a stronger signal than the one with the Faraday cloth.
Even if the SWR wasn't absolutely perfect 1.1 sometimes.
Correct. The difference wasn't, visually massive on a signal meter maybe, but he calculated it as over a 10% increase in signal strength with the radials.
Okay, so that suggests the radials were helping the antenna radiate more efficiently, even with a slightly imperfect match sometimes.
That seems to be the implication. Brett really framed it as that classic trade-off. You get amazing convenience and speed with the magic carpet.
But you might sacrifice some potential performance compared to putting in the effort for a decent radial system.
Exactly. It really depends on what you, the operator, value most for that specific activation or setup. Convenience or squeezing out that last bit of performance.
That's a really good point. In ham radio, especially with antennas and portable stuff, it's almost always about balancing those factors, isn't it?
It really is. There's rarely one single best answer for everyone, everywhere.
So let's circle back to Denny K5DCC for a moment. His experience was quite positive, calling it that perfect solution for portable use. What else might have factored into his conclusion beyond just, say, SWR?
Well, I think the practicality was huge for him. Like Brett mentioned, the sheer ease of just rolling out or unfolding the Faraday cloth versus measuring, untangling, and staking out wire radials.
Yeah, especially if you're trying to set up fast or maybe in a small space like a park bench area or something.
Exactly. That ease of deployment is a massive benefit. So his perfect solution, conclusion, likely weighed that convenience very heavily alongside getting, perfectly acceptable SWR and performance for his portable operating needs.
That context is crucial. It's not just about the numbers on the analyzer, but the whole experience. Okay, now let's bring in Michael, KB9VBR from KB9VBR Antennas. He also tested Faraday cloth.
Right, and he actually compared it to another portable alternative people sometimes use aluminum window screen.
Interesting. Did he confirm the cloth was actually conductive first? Basic check, but important.
Yep, checked it with a multimeter, definitely conductive. But then he did more detailed measurements, SWR, impedance, resonance, across a few bands using a quarter-wave vertical.
Okay, what did his numbers show? How did they compare to, say, Denny's findings?
Well, on 15 meters, his results echoed Denny's positive experience pretty closely. Very low SWR, 1.09.1. Resistance was good, around 53 ohms, not much reactance. And he noted good bandwidth, too, performed well across the whole band.
So more evidence supporting Denny's findings, at least on that band. What about 20 and 40?
20 meters was also pretty good. SWR 1.13.1 in the middle of the band, resistance around 56 ohms. Again, quite respectable.
Sure.
But 40 meters, similar to what W2I saw, it got a bit trickier. SWR was decent at the low end, 1.15.1, but crept up to 1.5.1 at the top end. Resistance was a bit lower, around 43 ohms.
And he mentioned something about needing more material on lower bands.
Yeah, he observed that getting that really good match seems to get harder on lower bands like 40 meters unless you have, a bigger piece of the cloth, which makes sense electrically.
Right, lower frequency means longer wavelength. But he actually used it for a POTA activation, Parks on the Air. How did it do in the field?
He did. And he said it performed well. He made contacts comparable to how the window screen had worked for him previously. He actually called the PSCA activation a rousing success using the Faraday cloth.
Nice. Real-world use is key. Did he mention any downsides?
He did. He praised the portability, lightweight, folds up small. But he also noted the cost. I mean, this stuff isn't always cheap. And also it's light. So wind can be an issue. It might try to blow away if not secured.
Ah, good practical points. The wind thing especially. So again, trade-offs.
Always. And Michael also did some WSPR testing, comparing the Faraday cloth against wire radials and the aluminum screen.
WSPR, that weak signal mode again. What did that comparison show? Any major differences?
Interestingly, he found minimal performance differences between all three, the wire radials, the screen, and the Faraday cloth, in his WSPR tests.
Really? So for those super weak signals, the cloth held its own against radials in his setup.
That's what his results suggested. It implies that, at least sometimes, the Faraday cloth can be a perfectly viable ground plane, even for making those challenging weak signal contacts.
Okay, so let's try and synthesize this a bit, especially keeping Denny's positive, perfect solution for portable use in mind.
Well, I think Denny's conclusion holds up quite well when you prioritize portability and ease of setup. His direct comparison showed it worked effectively in that context.
And Michael's results, particularly on 15 and 20 meters and his successful POTA activation, they seem to back that up, right? It can work well, especially on higher bands.
Absolutely. The Faraday cloth seems to genuinely shine when convenience is paramount. Denny's experience really highlights that value proposition for portable operators.
But the other tests, like W2A's and parts of Michael's and Brett's, introduce those caveats. Band dependency, maybe not quite the same peak performance as a really optimized radial system, especially on lower bands.
Exactly. So Denny found it perfect for his portable needs. Others found it good, but maybe not universally better than radials in all situations or on all bands. The consistent theme, though, is that portability and ease of deployment. That's where the cloth really scores points.
That seems like a very fair summary. It really empowers you, the listener, to weigh those factors. If getting on the air quickly and easily from anywhere is your main goal, Denny's experience suggests the Faraday cloth is a very strong contender.
Definitely worth considering. But if you're at home or you have the time and space and you really want to optimize for every last bit of signal, maybe traditional radials still have an edge, particularly for lower frequencies.
It comes down to experimenting with your own gear in your own situation.
As always in ham radio, see what works for you. The data suggests this Faraday cloth is a legitimate tool to have in your portable kit.
Okay, that's incredibly helpful. It clarifies the trade-offs nicely. So here's a final thought to leave you with as we wrap up.
Go on.
With material science always advancing, what's next? Could we see maybe even better conductive fabrics or maybe some totally different material innovation that finally gives us both ultimate portability and top-tier ground plane performance without compromise?
That's a fascinating question. What does the future hold for portable ground planes? Definitely something to think about.
Indeed. Until our next deep dive.